Hi everyone, welcome back to another episode of Why Should I Care About Water Management? And today we're going to be focusing on stadiums and specifically some of the projects that STRI have been involved in globally, where we're being increasingly asked to have a water management element to the design. So we've got Lee Collier today, one of our senior design consultants at STRI. So I'll pass over to Lee. He can introduce himself and take us through a few case studies, and then me and Charlotte have got some questions to ask him at the end of the presentation.
Hi, my name is Lee Collier. I'm a senior design consultant at STRI, and I'm going to talk about stadiums and typical water management issues. First case study that we have is a stadium in Russia, and I went on a visit to the site and actually saw the model in the foyer of the architect's building. And within the scheme, they had a green roof, a bunch of buildings to the right hand side with green roofs, blue roofs, a massive area in the middle with landscaping, and the stadium plonked on one side. And there was no joined up thought about how they could integrate water management within the two. They sort of taken key water management ideas, but it was fragmented. There was no joined up thought about how they sort of integrate the systems. So it was something that we'd obviously been thinking about at STRI, was how we can look to manage water across a precinct within the stadium in terms of water recycling and also attenuation in the stadium from roofs, from surrounding areas, from parkland. But in this situation as well, it actually was a real urban environment, including a housing development, and there was a real opportunity to integrate green infrastructure across the precinct, and they'd not really got on board with that idea. Unfortunately, it was a little bit late at that point to do that. So it was a bit of a missed opportunity, but I did think it was a really, really good case study of where they could have gone with that particular project. And it's not unique. We've been involved in a number of developments, especially in the Middle East, in stadiums over the last few years, and they are the precincts are quite large areas, multifaceted areas with large green areas, landscaping, car parking, and areas where for roads and access. So there's lots of opportunities to integrate water management within these areas. And you can see that there's also, in terms of green spaces, the football pitches take up a big footprint of these areas, and there's potential to integrate those within the water management strategy, which is sort of one of the key ideas of what we've looked at with things like permavoid, water storage beneath pitches, or gravel layer replacement specifically. Another case study of a project that we worked on fairly recently was with slightly different constraints, and this is going into an existing stadium where it's a limited footprint, a high water table. Obviously, it's in an urban environment, so there are huge constraints in terms of the amount of water that they're allowed to discharge from site. And they wanted to look at ways to attenuate water from the pitch and surrounds beneath the pitch and store that in a storm event, and then obviously discharge at a later time. So we came up with different different design solutions to that problem, looking at different depths of attenuation beneath the pitch profile, but within that incorporating all the normal pitch elements and normal pitch technologies such as vacuum and ventilation systems, that kind of thing. So that in terms of the actual profile build-up, we looked at different depths of attenuation, and also maintaining things like passive irrigation within the gravel replacement layer of the pitch profile. And this type of solution lends itself quite well to a soccer stadium, obviously, because it's a tensile raft. It forms a very flat surface on which we can build up the pitch profile and ensure that we have the type of tolerances that we require at the surface. It's also load bearing, which is obviously something that we need in this situation because we import root zone layers on which we have the turf surface. On another project looking at in China, we're looking at internal water management of a stadium. At the moment, this is at the planning phase, and they're looking at ways to pretty much internally manage water, but also recycle that where possible, not only for pitch irrigation, subsurface irrigation, but also for grey water for use around the building. So to capture that water, store it underneath the pitch, and then discharge it when they can, or reuse that. So it's almost like a closed loop to some extent. So we worked on a flow diagram, just going through that process, looking at the different types of water inputs to the surface. So we've got some pitch irrigation water, some water is obviously coming from stormwater in specific events, and where that's captured to the actual natural turf surface, but also to the surrounds, and then also to the stadium roof, and how we capture, collect that water, and then store that until we can recycle or discharge it and reuse it within the stadium. So it's a real opportunity to manage water in a smart way within a stadium environment.
Just on that, Lee, in terms of kind of rough numbers, a stadium roof, I appreciate China's very different to the UK, but how much water are you kind of talking about from a stadium roof during some of these storm events in terms of volume?
In that kind of event, it would be a serious amount of water. So it's hundreds of cubic meters, maybe even thousands of cubic meters of water, depending on whereabouts we are in the world and the type of storm event and the duration of that event. So we're looking at some fairly serious volumes of storage that's required. And in a typical situation within a stadium, that storage might be require excavation or tanks. And that obviously takes up some of the footprint of the stadium, which is expensive. It's obviously difficult to install as well. So if we can remove that requirement from within the internal structure of the stadium, where space is expensive and difficult to manage, and move that beneath the pitch where it's relatively easy to install, then obviously there's a huge advantage in that. Then if we can also, once we have the storage, if we can then ensure that all the pitch technologies are then included, so vacuum and ventilation, conventional irrigation system, all the stuff that you would normally expect to have on a pitch is integrated within the solution, then the groundsman has pretty much a pitch which will perform to the same level as it would have done with conventional technologies. And in some ways, maybe even better, because we've got passive irrigation, and there's an opportunity to look at zoning different kinds of technologies like vacuum and ventilation systems, because we're using a raft rather than conventional pipes beneath the pitch profile. So in the diagram in front of you, you can see that this is a way that we might deliver air into the into a permavoid raft by using a plenum created from the crates themselves, and then that is fed back to an oversized fan, which then sort of drives it's almost like based on an air conditioning system, but beneath the pitch, to move air either in vacuum or a ventilation mode to push air and pull air through the pitch profile, which is agronomic benefits.
Lee, in some senses, sorry to jump in, I just had a question. Would you say that actually using the permavoid system can lend itself to a sort of lower maintenance burden to groundsmen and people trying to implement these sort of schemes, if you've got this integrated approach below ground with the ventilation?
I guess it's in some ways it's simpler, and it's not so much low maintenance. I think maintenance would be probably around the same, because they're effectively drainage systems. But what you have is a greater opportunity to integrate different technologies. So, for example, with a conventional system, an aeration system, you couldn't integrate a passive irrigation system. But with permavoid, you would have the opportunity to do that. So it's what's possible in different scenarios is there's more opportunity to include different technologies with this approach. and integrate different technologies. So we talked a little bit about passive irrigation, and I think previously Christian sort of touched on this in more detail, but obviously within a pitch profile, if we can store water, then there's an opportunity to use that in a passive way through capillary action to provide water from the bottom up, which provides a significant benefit in terms of irrigation volumes. And in certain areas of the world, for example, the Middle East or other hot areas, then that becomes a real advantage, where water is obviously very much more valued. So where we can include that kind of system, there's a huge benefit, and we've included it in a few projects in those areas. One of the ways that that's managed is by using a sort of a environmental cascade, which I think Tom's talked about before as well. A control system which allows the permavoid to preempt storm events and be managed in a smart way around particular climatic events, so that we can have control the water level within the permavoid.
So I've got a couple of questions, but I'll restrict it to one. Obviously, you've shown some projects globally, so from China to Russia, and we also have quite a few sort of challenges in terms of translating some of the technologies and the concepts from place to place in terms of the way people usually would do design, the way people approach design, at which stages, and I suppose in relative terms on a scale, sort of how forward thinking people are. And do you find the same thing when you're approaching projects in other countries? Because we obviously have teams in different places, but some of the challenges are both the same but quite different at the same time. You know, we find that when we're doing projects, for example, in the Middle East, there's a real challenge around sort of awareness with the engineers of what certain passive irrigation technologies can deliver, integrated design. That's something that's still very much being piloted and learned over there. Is that sort of a similar experience for yourself?
Yeah, completely. I completely agree. And it's a really good and interesting point. I think in terms in Europe, the language is really familiar, and people are quite familiar with the concepts. So in some ways, having that conversation is far easier. But when you go to the Middle East or even further east to Hong Kong, China, then they are aware of sustainable drainage, but the integration of that is a bit of a foreign concept. So some of the projects we've been working on more recently, it's a bit of an education thing for them. They do have sustainable drainage systems, especially in Hong Kong. There are a number actually, but they are quite huge. There is one at a racecourse called Happy Valley, and there's a pitch in the middle of there, and beneath that pitch there's an attenuation system, which is basically 2 meter high concrete void, which is almost like a car park, which they've built, which must be extremely expensive to fulfill the requirements of managing water across that entire site. And I think there are more sensitive and ways of approaching water management across a site by integrating something a little bit more sympathetic like permavoid, or integrating different technologies in different areas with passive irrigation bolted on, that kind of thing, and more of a joined up approach rather than just one big attenuation device.
So it's about sort of dividing things up into subcatchments, looking at smaller scale and being a bit more sensitive. I think I definitely would echo that.
Completely.
Yeah, definitely. I think that's, for me, it was a big take-home point. And I know learning about stadium builds, etc. You realise what a great opportunity it is. You've got all these, as you call it, Charlotte, individual subcatchments, and they should be speaking to one another.
Absolutely.
Just one thing, I know we've dealt with this a few times, Lee, in terms of water quality. You're harvesting water from different surfaces. What kind of assurances, and is it something that's raised quite a lot of the time about irrigating from below for kind of a high-end pitch.
It is, yeah, and again, usually we have quite strict water quality requirements, so then that's dealt with in terms of the recycling systems that are integrated within the scheme. And I guess some of that depends on the water quality in the first place, and where water's coming from on site, what we're recycling, as to the specific requirements for water recycling technology, osmosis equipment, that kind of thing.
Yeah, definitely. Well, I think we'll leave it there. I think there's definitely a lot more in this stadium environment that we can pick up on later episodes, because it is quite a complex system we're dealing with. So thanks, Lee. Thanks for your time. And
Thank you.
we'll leave it there for another episode, and hopefully you can join us again soon.
Cheers. Thank you.